discuss the probability, all right? And today we're talking about theoretical probability. When you hear the word probability, I really want you to think about the word odds, right? What are the odds of something happening? Probability, as you can see in this photo, is the science or study of the chances of an event occurring, right? So it's like, what are the odds something might happen? What are the chances something might happen? And in probability, you have a scale, right? It's called the scale of probability. We can see right there. And you have basically 5 different ways of saying what are the odds or what is the probability. You have impossible, unlikely, it probably won't happen. Sometimes it might, it's probably equal. More than likely, it probably will, or it for certain will happen. And if we look at these spinners, right, this kind of gives an explanation of what that means in the scale of probability. So something that's impossible is that this is a spinner, right? There's 4 different options and they're all blue. The spinner will never, it's impossible to land on red, right? Because there's no red colors. Now, on the next one, in unlikely, right? It is unlikely that a spinner will land on yellow. The reason why, so it's possible, but it probably won't happen. If you count the amount of reds, which is 7, compared to the yellows, which is 1, and the way they're organized, it's more than likely that it will be a red spinner. All right? Sometimes, like we see here, there's an equal chance, right? A 50-50 chance based on how it spins. Okay, so the spinner will sometimes land on a red. There's an equal chance it will also land on a green. More than likely means it probably will happen. So now we look at it, it's the opposite of unlikely, where there's more green than there is blue. And then certain, if we see this is all red. Now what are the odds that the spinner lands on a red? It will always land on a red. So that's just kind of the language that we should start using throughout the next couple of lessons. But today we're going to talk about theoretical probability. All right, theoretical probability is the likelihood that an outcome will happen. All right, so how likely is something going to occur? So what we need to know is that this is the fraction. This is how we set up all of our probability. What we have is we have the number of the favorable outcome, right, over top of the number of the possible outcomes. Right, so what you do is you think about how many possible outcomes can there be, and what is the one that you're trying to look for. Right, so if we go back up to this image, and we even look at, well, this circle right here. If we're trying to land on red, right, the favorable, what we want, favorable, we always want favorable. There are 7 favorable outcomes of red, and there are 8 total possible. If that's a little confusing, I suggest you go with this one. Alright, so essentially it's like the numbers of ways something can happen. So how many different ways can you get red? And then the total number of outcomes. And we're going to speak to this more. So our example that we're going to talk about for theoretical probability is about rolling dice. Alright, so for example, Ms. Zoe and I, we're playing a game, right? And we're rolling 2 dice. It's a 6-sided dice. That means each side has, as you know with the dice, has 1 to 6, all with a different side. What's happening if the product, that means if the 2 numbers are multiplied together, right? If the product of the 2 numbers that is rolled is odd, I will get a point. If the numbers, so I'm going to highlight that in blue. All right, so I'm going to say odd. Think of it, I'm an odd guy, so I'm Mr. Callum. Oh, not Mrs. Lee. Once again, I always catch myself having to edit at least one of these. Miss Zoe. Okay. Now, if the product, once again, and that's the 2 numbers that are rolled, because we're rolling 2 dice, if we multiply them together, if it's even, then Miss Zoe will get a point. The first person to get to 20 points win. So without even playing the game, we should be able to say who is more likely to win. Who is more likely to win, and that's what we're going to find out. So theoretical probability can help us to determine the answer to this question. So what we did is we organized all the possible outcomes. As you can see on the top here, this would be dice number, oh, that's a bad D, but that's dice number 1, right? So when I roll it, I can get anywhere from 1 to 6. And this is dice number 2. Once again, I can get anywhere from 1 to 6. These are all the possible outcomes. Now we're multiplying it together, right? We're multiplying it together, so that's why there's a little x right here. So first we organize the outcomes. Each number on the die has an equal chance of being rolled. From the table, we can see how many possible outcomes are there. So if you count all of these squares, right, we're not going to include the other options here, but if we include all these squares, it is going to be 36 possible outcomes. How many evens can I roll? So again, I'm going to see how many times can Miss Zoe. So evens are anything divisible by 2. So 2, 4, 6. I should probably be counting how many. So that's 3, 4, 5, 6, 7, 8, 9 even numbers. 10, I've lost track. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right, so I count that there are 27 even products. So if I roll 2 dice, right, of the possible 36 outcomes, 27 can be even. Now I want to see how many can be odd. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, 9 can be odd. So what we can do now is we know enough details that we can actually go through, right? So we go to the formula and we can calculate the probability for each of the options. All right, so for even, all right, so first of all, the favorable outcome. So we want even. How many times will we roll even? Well, we said that you can get 27 different ways you can get a product that is even. How many total? You have 36. Okay, so what we did, again, is we said how many times can we get an even product, which is 27, and then we have that over top of, that's a fraction, I just don't have a lot of space, right? And then we have how many total possible outcomes there are, and we already said that's 36. And what oftentimes we do then is we take that number and we divide it. So 27 divided by 36. So you have a 75% chance of getting a product that is even. Right? So then you say, well, what is the probability of rolling odds? So there are 9 possible ways to get odds out of 36 different possibilities, or 25%. And that's all it really is. It's identifying the percent or the probability. Okay? Each of these probabilities are a theoretical probability. Okay, so each of these probabilities is a theoretical probability. So that is one kind of question that you're going to see. Oh, we're not done yet. So the probability that I win, Mr. Callum wins because I was odd. The probability I win is, so I got to get my marker out, is 9 out of 36. And the probability that Ms. Zoe wins is, because she's even, is 27 out of 36. Now if we write this, right, so since 27 out of 36 is greater than 9 out of 36, Miss Zoe's going to win. So I remember when we were doing greater than and less than when we were still in class, a lot of times you guys said, well, I just know by seeing it. Right? All this is doing is we're writing a statement that shows, because the question was, if you remember what the question was, it's who is more likely to win. So just because you find the probability of even and odds doesn't mean you've answered the problem question yet, right? You still need to say, Miss Zoe is going to win because there's it is more likely, 27 out of 36 is more likely to get a even number than odds, which is 9 out of 36. That's just how you represent it. Example number 2. All right, so a jar contains 5 blue marbles, 6 red marbles, 7 green marbles, and 7 white marbles. Without looking, a student randomly picks a marble from the jar. So what we need to first say is, what are the possible outcomes? All right, so if you reach in a jar, this jar, and you pick it out, what is a color that you can possibly get? And that is blue, red, green, or white. All right, those are the possibilities you can get. I want to know what the theoretical probability of picking a green marble. So the first thing you need to do is you need to go back to the question and identify how many green marbles there are, right? Because that is the favorable outcome that we want. We want green, it's favorable, so there are 7 greens available. The bottom number is going to be the total outcome. So I want you to do some math as I write this, and I want you to see if you can guess how many total marbles there are. Okay, so if you're adding up, you should be adding up all the marbles right now in the top right here. So we take that 5 plus 6 is 11, plus 7 is 18, so I can even write that out. 5 blue plus 6 red plus 7 green, it's a bad 7, and 7 white. When you guys get back in the classroom and you don't have to struggle through watching me do this with a trackpad, you're going to be so happy. Math's going to... So this is 5, 6, 7, that's a G, not a 9. So you add those together and you're going to get 25 total marbles. So the probability of picking a green marble is there's 7 green marbles out of 25 total marbles. Alright? So I hope that so that's basically probability and what we're introducing. This is our assignment here. Alright, you need to get that done. It's pretty straightforward. And here's some extra practice in case you want to practice it, right? Once again, you see very similar questions where they give you the number and you're looking for the probability of each one. Alright, so oftentimes you're going to describe it in a fraction or a percent. A percent, you turn this, you just have to divide the top number by the bottom number, and that should be 28%. You have a 28% chance of drawing a green. Okay? So yeah, get this done. Let me know if you have any other questions.